Is the younger dryas theory a real thing? So, what is this younger dryas theory? First of all, there is a set of events that actually happened, and then there's a theory. So, what is the set of events that actually happened? So, about 12,900 years before today, there's a sudden onset of cold weather all across the planet. Sudden ice age. Okay. See, let's find out the last glacial minimum. Last glacial minimum. Last glacial maximum. Maximum. The last glacial maximum was about 29 to 19,000 years ago. The coldest, most intense phase of the last ice age, featuring maximal global ice sheet expansion. Glaciers covered about 8% of Earth's surface, 25% of land, and so on. The sea levels dropped by 120 meters compared to what we have today. The world was significantly colder, and so on and so forth. The last glacial maximum was between 29,000 to 19,000 years ago. Average temperature. What was the average temperature in the planet? 8 degrees Celsius was the average global temperature. Okay, so that is the last glacial maximum. Now, what about the younger dryas period? That's about 12,900 years ago. Period. Okay, 12,900 to 11,700 years ago. About 1,000 or 1,300 years it lasted. Okay, average temperature. So the average temperature at that time, what was the average temperature? Okay, it's showing you how much it fell. So in Greenland, the temperature fell by about 10 degrees Celsius. Imagine a drop of 10 degrees Celsius. And the northern hemisphere annual temperatures dropped by about 3 to 5 degrees Celsius. So this younger dryas period was a period of about 1,000 years, 1,300 years, beginning 12,900 years before today, where the global temperatures abruptly dropped. Abruptly, sudden drop across the world. Maybe in the northern hemisphere where we live, most of us, it was 3 to 5 degrees Celsius kind of drop. In Greenland, it was about 10 to 13 to 15 degrees of drop in temperature. That's massive drop of temperature. And this happened abruptly. It lasted for about 1,000 or 1,300 years, and then it disappeared abruptly. So for these temperatures fell in a period of about 50 to 70 to 100 years. In just about 1 century, the temperatures dropped that much. Then this period lasted for about 1,000 or 1,300 years, and then about 30 to 50 years, the temperatures went back to normal. So that is the younger dryas period. Now the question, so it actually did happen. The question is, how did it happen? What was the causative factor or set of causative factors? That is the question, and that's where the controversy arises. So I'm not sure what the officially accepted consensus is as to the causative factors for the younger dryas cooling of the Earth. But there's another theory. The theory is that there was an impact event, maybe an asteroid or a comet that hit the Earth, or maybe broke into pieces and hit multiple parts of the Earth and multiple air bursts and all that. And maybe a lot of dust and soot was pushed up into the atmosphere, which cooled the planet for about 1,000 or so years. That's a theory. That's the younger dryas impact theory. And it's been put forth by people like Graham Hancock. Younger dryas impact theory. The question is, what evidence do we have that such an impact happened? Maybe a cometary impact or an asteroid impact. Did we have single impact? Did we have multiple impacts? Sometimes comets and asteroids break up and they hit you in multiple places. That sort of thing also happens. So do we have any evidence of an impact event? There's this Greenland impact crater that's been discovered recently. So Greenland crater, younger. Yeah, so it kind of dates to that time. 31-kilometer wide Hiawatha crater. Initially suspected, blah, blah, blah. It's okay. It happened 58 million years ago. Oh, well, that's tragic. It's 58 million years older than the younger dryas thing. Okay, so I remember seeing this news that there's this crater that's been discovered in Greenland that kind of could prove the younger dryas impact theory. But now, I didn't look it up until now. So it's 58 million years old. Well, that's sad. So I'm not sure if there's any evidence that corroborates this theory, the Younger Dryas impact event theory. So most scientists and researchers do not treat this theory very seriously, primarily because of a lack of evidence that supports it. But it's still theoretically possible. So maybe the impact creators are hiding somewhere. Maybe we haven't discovered them or something. That's also a possibility. But in the absence of, so the absence of evidence is not evidence of absence, but we need to have evidence before we take a theory seriously, and we don't have it right now. And there are some other pieces of evidence, very circumstantial evidence. There is Gobekli Tepe, a swarm of planets kind of thing. Okay, Gobekli Tepe, the carvings there, cometary swarm. Let's see. Ancient carvings on Pillar 43 are interpreted as a record of a devastating comet swarm impact about 10,850 BC. Younger Dryas thing. Okay, let's see Pillar 43 at Gobekli Tepe. Gobekli Tepe. What's it look like? So do we see a swarm of comets? I can see a scorpion. Do I see a swarm of comets? I'm not sure if I see a swarm of comets, but I don't know. Maybe some people see that. So it's a very circumstantial, far-fetched kind of thing, but some people interpret that pillar as some kind of record of a swarm of comets appearing and impacting the Earth and setting off the Younger Dryas period. But clearly, that's just very, very circumstantial and very far-fetched. Can't be taken as proof.